Okay, so in this section, we wanted to talk about the partial fractions. Okay, so what will be the partial fractions when we have decomposed the fractions into several linear, has only linear factors, repeated linear factors, has non-repeated prime factors. We wanted to decompose the fractions into several, small factors. Okay, so that is called partial fraction. Okay, so the partial fraction decomposition of px over qx when qx has distinct linear factors. Okay, so if you have distinct linear factors for the denominator and we wanted to separate it as the addition of several, small fractions together. Okay, so what should we do? Okay, so the first step, you set all the partial fraction decomposition with unknown constants a, b, c. Okay, so if this is a linear one, a1x plus b1, then on the top you will have a constant. And if here is a quadratic equation, a1x squared, then it will be a linear one. Okay, so it's always one power down, one power less. Okay, and then we wanted to simplify and find the a1, a2, a3, an here. Okay, so what should we do if we wanted to find the partial fraction decomposition of 5x minus 1 over x minus 3 x plus 4? So what do you have here? You have 5x1 equal to, we wanted two separate fractions, yeah? A over x minus 3 plus what? B over x plus 4. Okay, so what should we do? I think I have, yeah, so this is what I'm doing. So we will skip all these details. We will do it step by step with you, okay? So what will you do here? So you have 5x minus 1, x minus 3, x plus 4, yeah? So equal to a over x minus 3 and plus b over x plus 4. So what will we do? We wanted what? Common denominator. So what is the common denominator? X minus 3 times x minus 4, yeah? So you have to multiply x plus 4 here, x minus 3 here. Now, what do you have? You have the common denominator on both left and what? Right, yeah? So then you can forget it. So what do we have? You have 5x minus 1 equal to ax plus 4 plus what? Bx minus 3. Okay? In the book, what they wanted to do is they wanted 5x minus 1 is ax plus 4a plus bx minus 3b. And then 5x minus 1 is a plus b x plus 4a minus 3b. So method 1. Okay, so then what will they do? They wanted to compare the coefficient. So this means the coefficient of x has to be the same. A plus b equal to 5. And then 4a minus 3b equal to what? -1. Then you solve for a and b. Okay, so this is the method from the book. Okay, so and it's kind of complicated here. Okay, so it's a lot of work. Okay, I will introduce a method is called what? Use special values. Okay, so because 5x minus 1 equal to this for all x values. Okay, so what I will choose? I will choose, let this one equal 0 and let this one equal 0. So you can choose x equal to -4. Okay, so what will you get for x equal to -4? So what will you do? I just choose the equal to 0 on the denominator. Okay, so x equal to -4 or x equal to 3. So when x equal to -4, what do you have? 5 times -4 minus 1. So what do you have here? A times what? 0 plus b -4 minus 3. So what happened? A is gone, yeah? So what do you have? -20 minus 1 is -21 is -7b. What will be b? 3. So when x, the second one you wanted this one to be 0, yeah? So x equal to 3. So whatever you have, 5 times 3 minus 1 is 8 times 3 plus 4. So you have 7a equal to what? 14. So what will be a? 2. And when you do this, your a is equal to 2 and b equal to 3 too. Okay, so these are the two methods. Okay, so if you can choose whatever one you like. Okay, I think this one is a little bit easier. The calculation is a little bit easier. Okay, so this is what we should do. Okay, so and then for the partial fraction decomposition of px over qx, and qx has repeated linear factors. So what means repeated? Means you have a power here. When you have a power, what should we do? We have to start from the power 1, 2, 3 until the power of that, that y is given. Okay, so this is a special case. So like x plus 2, x over x minus 1 and 1 squared, then what will you have? You have x, but x minus 1 term, it is not only power to the 1, so it's power to the 2. So you have to have x minus 1 and then x minus 1 squared. If you have cube, then you have x minus 1 squared, and then x minus 1 cube. Okay, so then what should we do with this one? Okay, so it's similarly. So what will we do? Common denominator, yeah? So the first term you have x. What are you missing? So because this is the common denominator. Okay, so you have x. You missing x minus 1 squared. So you multiply. Here you have x minus 1. You're missing another x minus 1, and you also miss x. Okay, so for here you have x, yeah? Okay, so what do you have here? You have this. Okay, so what are the typical zeros you wanted to choose? You special values, you can choose x equal to 0 or x minus 1 equal to 0. So this is x equal to 1, yeah? So whatever you choose, you can choose x equal to 1 and x equal to 0. When x equal to 1, this term goes away. So you only have 3 equal to c. And when x equal to 0, so you have 0 plus 2 equal to, so a equal to 2. Okay, but we do not have any other special values anymore, yeah? Then what should we do? You can choose what? Any other x value. You can choose a different one, such that the calculation is not so bad. So you can choose x equal to 2. 4 equal to a plus 2b plus 2c. 4 equal to what? 2 plus 2b, and b equal to what? -2. Are you with me? And then, what's your answer now? It will be what? A, what is a? 2 over x plus b. Okay, so, because b is negative, so you have negative 2 over x minus 1 and plus c. What is c? 3 over x minus 1 squared. Okay, so this is your ABC, yeah? Okay, so you find it, and you have already decomposed this fraction. Okay, and the method from the book is similarly as before, and you are what words you do, you are compare the coefficients. You are compare the coefficients here. Okay, so this means if you combine like term, So do you have an x squared term here? No x squared term. What does this mean? A plus b has to be equal to 0. So do you have an x term here? You do. So what is the coefficient here? It's 1, yeah? So then this means the negative 2a minus b plus c has to be equal to 1. Then the constant term has to be equal to a. So this one is not bad either, yeah? So a equal to 2, a plus b equal to 0. So what will be b? B equal to negative a with negative 2. Then what will you do? Substitute both here, then you get the other one. Okay, so then you get c equal to 3. Okay, so then it's the same thing as we did it. Okay, so the last one is when you have a qx has a prime quadratic factor. When you have a quadratic factor, what should we do? Okay, so as I just briefly mentioned, when you have ax squared plus bx plus c, so your top is not a constant anymore. It will be a linear function, ax plus b. ax plus b. Okay, this is super important. Okay, super important. Okay, so what should we do here? So this means a at x squared plus 12x minus 20x plus 3, x squared plus x plus 2. So a over x plus 3, bx plus c over x squared plus x plus 2. Okay, and for this one, I think it will be easier for the method, the book's method. Okay, so is ax squared plus x plus 2, yeah? So common denominator plus bx plus c times what? X plus 3. So you have 8x squared plus 2x, 12x minus 20. So what do you have? ax squared plus ax plus 2a and plus bx squared plus cx plus 3bx plus 3c. So what do you have? A plus bx squared plus what? A plus c plus 3bx plus 2a plus 3c. Yeah, then what will you do? Compare the coefficient, yeah? So what will you get? Yeah. Yeah, so this is the compare. So when you compare the coefficient, yeah, so this is this step. It's a plus b equal to 8, a plus 3b plus c equal to 12, 2a plus 3c equal to what? Negative 20. Okay, so what will be the easiest way to do it? Yeah, you can get rid of b, maybe, yeah? So because what is b? Is 8 minus a, yeah? And then you can substitute here. So what will you get? A plus 3 times 8 minus a plus c equal to 12. And then is what? 24 is negative 2a plus c equal to negative 12, yeah? And then you have equation of AC, you have another equation of AC, and then combine them. Okay, so you can combine them. So it's the same thing. The book chooses the same choice. Yeah, so you have these two, and then you get C. And you get C. You back substitute again to find your A and B. It's me. Then you get the answers. Okay, and then what will you do? This is the most complicated case. What if you have a square or cube with the quadratic ones? Then you do it again and again. So it will be the repeat. ax plus b, and then you square it, and then cx plus d. Okay, so it's the same thing. So, but what will we do here? You have to do it, like, be careful when you what will you do? When you FOIL this, yeah, be a little bit more careful. So because here, actually, okay, so what will you do? You multiply x squared plus 1 on both top and what? Bottom, yeah? Okay, and so what will you get? I will not do it. I will only find the common denominator. So this is how you get it: ax plus b x squared plus 1. And then because here you do not need to do anything, so you plus cx plus d. Then what will you do? You FOIL it. When you FOIL it, what will you get? It's 2x cubed plus x plus 3. You have what? Ax cubed plus what? Bx squared. Oh, this one is not bad. Then you have a plus cx, and then plus d. What do we have? A equal to 2. Yeah. So b equal to what? 0, yeah. And a plus c has to be equal to what? 1. D has to be equal to what? 3. Wow, this is super easy, yeah. So a equal to 2, then what will you have? C. C equal to what? C will be equal to what? 1 minus a is 1 minus 2 is negative 1. So then what do we have here? Then it will be equal to a equal to 2, b equal to 0, c equal to negative 1, d equal to 3. Oh, super nice, yeah. So this tells you it seems complicated, but it's actually turns out to be easier than the other one, yeah. This is b plus d equal to 3. Oh, I'm lucky because b equal to 0, yeah, so I forgot. Yeah, so be careful when you combine like term. Do not be like me, yeah, so I forget one term. But I'm lucky here because b equal to 0. Yeah, so d equal to 3. Okay, so you get all these numbers, and then you substitute there. Okay, that's the end of the partial fractions.